Welcome to Hypothesis Tests on the Calculator, Part 2. This time we're going to do a t-test. It's very similar to a z-test, and I'm sure you can figure out a z-test on your own once we walk through this. Remember, you hit the Stat button, arrow over to Tests. If you're doing a z-test, it's choice 1, t-test is choice 2. You should have already watched the video on proportion testing, choice 5. This is what the menu looks like. So let's drop down past last video's work and try this sample. Let's say I took a sample of 20 students from my statistics classes and calculated their mean score on the first test to be 78 with a standard deviation of 6. I was shocked because I'm quite certain it should have been at least 80. I want to test this idea of mine with a 5% level of significance. What have we got here? Well, I took a sample of 20 students. Their mean score was 78 with standard deviation of 6. Sounds like that's a sample standard deviation to me. So I'm going to run a t-test. My null hypothesis is what includes the equal sign. And at least 80, that means I think my mean should be greater than or equal to 80. But we never use the inequality with null hypothesis, so we're going to say we think the mean score is 80. The alternative hypothesis has the inequality. And in this case, our alternative says the score is less than 80. What's the information I've got to work with here? I've got a sample size of 20. That means my degree of freedom is 20 minus 1, which is 19. I know X bar is 78. Sample standard deviation is 6. Alpha is 0.05. So let's go to the calculator, press the Stat button, arrow over to Tests, choice 2, the t-test. I'm going to use my input to be statistics. My hypothesis null is 80. My X bar is 78. My sample standard deviation is 6. N is 20. I'm choosing my alternative hypothesis in this next row. So I want to go with less than mu sub naught, and I'm going to calculate. My output this tells me for an alternative hypothesis mu less than 80, and I just have to know that's the alternative hypothesis. The test statistic t is negative 1.4907, etc. And I just have to know that's my test statistic. The p-value, p is 0.0762, etc. And we just have to know that p is the p-value, because we got a lot of p's in this class. And then they go on to tell me X bar is 78, SX is 6, N is 20. Well, I know that. I put that stuff in myself. So these are the two pieces of information the calculator is calculating for me. How would we use those? Draw your normal curve. Well, this time it's a t-curve. So we've got x values and t values. My hypothesis assumed the mean was 80. A t statistic has a mean of 0, just like the z. We found the test statistic to be negative 1.4907. I don't know what the x corresponding value is, but we could figure it out because we know that t is x minus mu over s divided by the square root of n. And I know all those values except x. I know the t statistic is negative 1.4907. That equals x minus my null hypothesis mean of 80 over my standard deviation divided by the square root of 20. And we could solve for x to get that value. If you're doing the critical thinking test, you should. This area is the p-value. Which is 0.0762. We were going to do a significance level test at the 0.05 level. That means 0.05 should be that area. And this point right here is the critical point. We could calculate that. We could do INVT for 0.05. That would give me the critical point as a t value. If I told it my mean was 8 and my standard deviation was 6 over the square root of 20, I'd get an x value. And are we accepting or rejecting our null hypothesis? Well, the acceptance region is from the critical point on over. So we're accepting the null hypothesis, but stat people don't ever like to say that. We say we fail to reject. However, what was our claim? Our claim was the null hypothesis, so we failed to reject our claim. We think maybe I know what I'm talking about when I say that should be at least 80. What does that mean? Well, it means I got a bad sample. I wasn't very random in selecting my sample. It should have had a score of, mean score of over 80. And that should get you through all of your hypothesis testing. Good luck.